All right, lesson 5 is more or less a continuation of working with functions. And remember, a function is for every input, there's only one output. The functions that we're working with today are both linear and exponential. And a lot of what we're trying to do today is get used to some new notation. And we're going to have you go through an exercise just to analyze some functions and then discuss what some of the notation implies. So um, our opening exercise asks you to take a few minutes and decide which plan is the best plan. There are 4 plans here. One says um, Aunt Lucy has decided to begin distributing her vast fortune to her nieces and nephews. She's given them 4 plans from which to choose. Once they choose a plan, they cannot change to another. So they want to pick the best one. However, kind of depends on how long Aunt Lucy lives or how long she's going to be able to continue to hand out the assets. So maybe it's even after a period of time, maybe it continues. So take a little bit of time and figure out how much money you would make if you received $10 in the first year, 20 in the second, 30 in the third, 40 in the fourth, and so on. In other words, we're adding plus $10 a year to our fortune, right? Plan 2 says we want to receive $100 in the first year, 90 in the second, 80 in the third, and so on and so forth. In other words, we're going to lose $10 a year, but we're starting out with a higher amount. Plan 3 says you're going to start again with $10, and each year you're going to multiply that amount by 1.5 times. So times one, you know what, let's make that times 3/2. 1.5 is 3/2. So it's going to grow each year. And then finally, we start plan 4. We start with $1, and each year it looks like it doubles. So 2, then 4, then 8, and so on. So times 2 each year. Now, again, you probably need to go ahead and stop the video um, and analyze which one's which. And I'll let you guys um, stop the video and work for a little bit. So as you work through this, clearly your choice may depend on how many years you anticipated receiving inheritance. So again, your choices are going to vary. The question is at some point, what is actually going to happen? Now, I went ahead and created a couple of displays. In the first one here, 10, 20, 30, 40, 50. After 5 years, you ended up with $150. Number 2, after 5 years, you ended up with $400. Number 3, after 5 years, you ended up with $131. And number 4, after 5 years, you ended up with $31. Now, I will tell you right now that this does not give you a clear picture of what could happen, but it's a start. Okay, now right off the bat, it appears number 2 might be a good way to go, but you know that year number 2, or after year number 10, you're going to run out of money. You're not going to get any more money. So we need to analyze some of these things a little bit deeper. Um, as we go through this, we're beginning to introduce some new terminology. So um, we are talking about using terms that are indexed so that we can order them. Uh, we call this a subscript. So if we start at um, a sub for the first plan, right? A sub 1, we knew that was $10. A sub 2, we knew we were going to get $20, but that resulted in $30 total. A sub 3 was $30. My result now is a sum total of $60. All the way down to A sub 6, okay? And A sub 6, again, would depend on um, um, what you're looking at. Are we looking at how much we're receiving in that month or in that year or the total? A sub 6 was $60. I believe at that point you would have a total of 100 or 200, $210 total. Um, but notice that the subscript refers to the year. Question number 4 says, which term in the second plan are 0? So in other words, when will you not receive any money? This may seem obvious, but obviously A sub 1, you're receiving $100, and if each year you drop $10, then by A sub A sub 10, you're receiving $10. So in year 11, A sub 11, you're receiving $0. So in the 11th year, okay, this is a subscript, A sub 11. When a function is expressed as an algebraic function, only the term of numbers in the index variable n, then the function is called an explicit form of the sequence or an explicit formula. Sequences can be indexed starting with any integer. To avoid confusion, this module adopts the convention that the indices start at 1. Now you're going to see that they don't always start at 1 at some point, but in general we're going to start at 1. So this is hopefully going to make things a little more clear. That way the first term on the list is always F1 or A sub 1, and there is no confusion about what the 100th term is. So remember, no, they just introduced a second subscript. So we got A sub 1. We understand that. That's the first term. But they're also saying, oh, we could also list this as a function and say F of 1. So in that sense, you're plugging in 1 for the first year or first week or whatever. So in a sense, we can use function notation also. The explicit formula for the first plan is f of n equals 10 times n, where n is the year the gift was given. Check that this formula holds for the pattern stated by Aunt Lucy. Well, remember we said a sub 6 equaled $60. So shouldn't f of 6 equal 10 times 6 or $60? So it holds true. The same thing would be true with the subscript. With your group, determine the explicit formula for the second plan. That's an interesting one. Okay, so let's talk about that. I know that for a general formula, f of n, for whatever number you're in, we have to get a specific number. Now remember our numbers went 10 or 100, 90, 80, 70, etc. So in this case, um, f of f of 1 we know is 100. So this is going to be something like 100 minus 10n. Now, how does that work? Um, if if I do that and I plug in the first year, then I'm subtracting 10 and only getting 90. So this didn't quite work up to speed. So we're going to have to make adjustments. How do I do that? So let's play around with this a little bit. Let's say f of 3. Now I know f of 3, the third year, right, is going to be $80. First year being 100, second year being 90, third year being 80. So the question is, if I'm starting with $100, I've got to subtract 20. So how do I get 3 to be 20? So this is kind of interesting. So if we're going to go 100 minus 10 times n minus 1 is a possible way of doing this. So if I plug in 3, right, I get 100 minus 10 times 2, or 100 minus 20, which is 80. So that works. We knew this didn't, so we're going to try again. Now, is there another way of doing this? Let's do this. Let's write it this way, and this is going to seem a little weird, but we had talked before about um, subscripts. If I had said f of n plus 1, that's going to be a year in the future, right? But if I go f of n minus 1, that'll be the previous year. So if I were to take the amount of money in the previous year, f of n minus 1, and subtract 10, I have my notation. Okay, and that's an explicit formula. So let's try that. Let's test that out. That means f of 3 is equal to f of 3 minus 1 is 2 minus 10. Well, f of 2, wasn't that 90 minus 10 or 80? So that's another way of doing this. What we're getting to here is referring to our subscript in terms of years. I think you've seen that already.